I'll go ahead and get started here. Good morning. Hope everybody's been having a great KubeCon so far. Thanks for sticking around to the last day and coming to my talk. My name is John Coyne. I'm a distinguished engineer of application engineering at Discover, which is now part of Capital One. And today I'm hoping to provide some insight on how you can efficiently scale a Spring Boot application in Kubernetes by using its application metrics. So a quick look at the agenda for today. I'm first going to do a little bit of a deep dive into the built-in functionality in Kubernetes for the Autoscaler, before I'll dive into KEDA, which stands for Kubernetes Event-Driven Autoscaling, and we'll see how that can augment the built-in HPA. I'll then showcase how Spring Boot can use a Java library called Micrometer to expose metrics to a metric provider called Prometheus, which can help us to scale our application. And I'll wrap things all up at the end and tie it together in a demo. So the first question I want to answer is, why do we want to implement autoscaling in the first place? Now, I think the first and most obvious reason is to save money. If you're deploying your workloads to the public cloud, then obviously the less resources you use, the more money you're going to save. The second is disaster recovery. If you're deploying your application to multiple clusters across multiple regions, it's probably for a good reason, for high availability and resiliency. If your public cloud provider were to say, go down in the East region on a Monday morning, whenever your traffic is receiving a high amount of volume, could you scale up in the West? And last is just to be a good steward of energy. Making sure that you're only using the resources that you need to run your application. Now, when we talk about scaling, there's really kind of two high-level types. You have vertical scaling, in which you add resources like CPU or memory to your existing instances. And there's horizontal scaling, in which you scale out the number of instances to your existing workloads. So the topic of today we're going to be discussing is going to be horizontal scaling. So Kubernetes has a built-in Horizontal Pod Autoscaler, or HPA, and it basically offers the ability to scale up or down the number of pods based on your demand. It currently works with either a deployment or a stateful set. And like many things in Kubernetes, it works in a control loop. Every 15 seconds, it tries to calculate the number of replicas that you need. It is a configurable setting, but the default value is 15 seconds that's set at the control level. Currently, what it offers is scaling on metric targets of either CPU or memory. And when it first came out, it just supported the pod metrics, but now, starting with Kubernetes 1.30, it does support container-level metrics. And it does offer the ability to use custom metrics by implementing the custom metrics API. And this is exactly what KEDA does for you to make it nice and easy, so I'll get into that in just a little bit. So the configuration options for the HPA, again, it has CPU and memory, so you can either use one of those two options, or you can configure both of them. And then you give a target type. So you have three different options here. The first one is the average utilization. So this would be based on your resource request. So for example, if you requested 500 millicores of CPU, and you're using 250, your utilization would be 50%. The next one would be average value. So there you would take the average of across all of your pods, come up with an average, and that would be your target. And then the last option is value. So that would sum together all of your pods and then come up with that as your target. And I'll get into a couple of examples of all three of these in a little bit. Now, as far as the calculation goes, the way it calculates your replicas is it takes the current metric value, divides by your desired metric value, multiplies by the current number of replicas, rounds that up to the nearest whole number, and that gives you your desired replicas. And a few other details about the calculation. So when that ratio of the current metric divided by the desired metric is sufficiently close to 1, within 1/10 in its configurable value, then it won't perform any scaling action. And then when you do provide more than one metric, it's going to calculate the desired replicas for each of those, and it will take the highest value. And then if there's any pods that are in a deleted state or they're failed, then it'll just be excluded completely from that calculation. So let me walk through a couple examples. First one, average utilization. Let's say that I've defined my HPA with a 70% average utilization as my target. And then in my deployment specification, if I have a resource request of 200 millicores of CPU, if I currently have two pods running with 120 and 108 millicores of CPU, what will be my desired replicas? So if I add those two together and divide by 2, I get 150. Now, if I divide that by 200, which is my CPU request, I get 75% as my current utilization. I divide that by my target of 70, that gives me 1.07. So this is within that 1/10 tolerance of 1, therefore my replicas would stay at 2. All right, the next example, average value. Let's say in this example I've set my HPA configuration to a target value of 50 millicores. If I have 4 pods running with the listed number of millicores of usage, if I calculate the average of those 4, I would get 30 millicores. I divide by my target value of 50, that gives me 0.6. Multiply by 4 replicas, gives me 2.4. I round that up, I get 3 as my desired replicas. The last example would be total value. So let's say in this example I have a total value target of 250 millicores. I have 3 pods running with the listed CPU usage. If I add those together, I get 505. Divide by 250, 2.02. Multiply by my number of replicas, 3. That gives me 6.06. Round that up. Now from the calculation, this would give me 7. However, in my configuration, I've only defined 5 replicas as a max. Therefore, the replicas would be capped at 5. Now this is a scenario called too many replicas. If you ever describe your HPA and you see this error message, then you probably want to take a look at the configuration and you have some adjustments to make. Now, when it's time to perform a scaling action up or down, there's some behavior that you can configure to decide how that works. Now, there's a stabilization window to ensure that you don't necessarily thrash up and down the number of pods. So what it does is it looks at a rolling period of history, and it looks for the maximum value in that period, and then it will use that as the desired replicas. And then when it is time to actually do that scaling, you can define how many pods that can go at in a single time period. And that can either be in a raw number of pods or a percentage of the current number of pods. So the configuration for that looks like this. You have in the HPA config, you have a behavior section, and you have both options of scale up and scale down. So the stabilization window seconds is you can configure from 0 to 3600, which would be an hour. Now the default values here are for scaling up, it's 0. Meaning as soon as a higher value is seen, it'll scale up immediately. For scaling down, the default value is 3600 or 5 minutes. Meaning when a lower value is seen for desired replicas, you need to wait at least 5 minutes and not see the higher value before it'll actually scale down. The policies are defining, again, how many pods you can scale up or down in a single increment. So this is a list that you can provide, and you have the option of doing %, pods, or both. So if you do define both of them, then there's a select policy that says, if I calculate both of these, do I want to use the higher value, the lower value, which would be min or max? And there's actually an option called disabled, and that effectively disables scaling down completely. So if we take a look at the default behavior, this is what we have. If you don't configure anything at all on your HPA, this is what you'll get. As I mentioned, for scale down, you get 300 seconds. Now, the policies for scaling down is 100%. That means if let's say your traffic just drops immediately or something, you can scale down literally all of your pods in just within 15 seconds. So pay attention to that. That might be something that you want to override. Of course, it won't go below your minimum replicas. So. And then for scaling up, as I mentioned, 0 is the stabilization window there. And for scaling up, there are 2 policies defined, both %, so effectively it could double, or go up by 4 pods, and the select policy there is max. So whichever one of those is greater is what the scaling up policy would use. I want to quickly walk through a visual example of the stabilization window in action. So let's say that for this example, I have my scale down stabilization window set to 60 seconds. Now I'm starting at 10 o'clock, which is, if you see in the bottom, I don't know if you can read it or not, but let's say at 10 o'clock it was 4, the current time is 10:01. So each one of these are the 15-second increments. So as I move the sliding scale over, you can see once I get to 10:01 and 30 seconds, now in that sliding window, my highest value is 3. Now as I move along, as you can see, there's still 3 as the highest value of desired replicas. And then once I get to 10:03, now is when I would scale down to 2. Now, sometimes using those built-in values of CPU and memory just don't cut it. This is an example of some metrics of an application of ours, where you can see on the left-hand side, is the load of the application. Around 3 a.m. it's kind of at its lowest point here. You can see on the first arrow. And then around noon or so, it's whenever it's at its highest point. Now, if we look at the correlated metrics on the right-hand side, there's the CPU usage. And if you can see the two orange arrows that correlate with those same timeframes, there's not that big of a difference in CPU there, right? And in memory, in a lot of Java applications that have kind of a finely tuned heap size that aren't using too much memory, because the memory is pretty flat. So you can't really use these. And we weren't able to effectively do that until we implemented KEDA. So KEDA, again, stands for Kubernetes Event-Driven Autoscaling. It's a mature CNCF Graduated Project that's been around for a number of years. Again, it extends the HPA to use metrics beyond just that memory and CPU. And in fact, there's over 70 different event sources that it can actually pull metrics from. In today's demo, I'm going to be going over Prometheus, but if that's not something available to you, check out their documentation. They have a wide range of things you can query from Postgres databases. You can go to APM metrics providers. There's a lot there. And something additionally that I can help you do is actually scale to and from 0. Now, what I'm going to be talking about today is pulling metrics from your application. When you scale down to 0, of course, your application is no longer there, so you can't pull metrics from your application anymore at that point. That's where you need like an external source to pull metrics from. Now, if you're talking about like a message or event-driven application that's pulling from a queue, that's pretty obvious that you can just look at the queue depth of a RabbitMQ or a Kafka queue, right? Now, if you're talking about an HTTP-based application, it's a little more difficult, right? You could be looking at metrics of like a load balance or Nginx or HA proxy. Of course, when a request comes in, if your application is not available, then it's, you might have a few requests that fail at the beginning of there. Now, there is an add-on to KEDA called the HTTP add-on that allows, basically what it does is it kind of intercepts HTTP traffic and holds on to it until you can scale up. Now, you probably want to be able to scale your application up pretty fast in that scenario. But I'm not going to be going into too much depth on that today. I just wanted to call it out to make you understand that it's available. But today I'm going to be focusing more on the HPA spec of it, where it's scaling from 1 to above 1. So there's a few different ways to install KEDA into your cluster. I think probably the most popular would be using the official Helm chart that they provide. And once you do that, you're going to have a number of components available. So like many things that you add onto Kubernetes, there's an operator that's kind of the brains behind the operation. Then you have the metrics server. So this is what the HPA or the control plane will be querying to get those metrics. And then the scalars are based on where you're pulling metrics from. Those are going to pull those metrics out, provide them to the metrics server. And then there's a number of CRDs that it installs. The one that you'll probably be dealing with most is called a scaled object. There's also a scaled job, but I'll be focusing mostly on the scaled object today. All right, so let's switch gears over to the application side of things. So Micrometer is a dimensional metrics library for Java applications. Sometimes it's referred to like SLF or J, but for metrics, right? With SLF or J, you can switch out your logging provider without making any coding changes. You just make a dependency upgrade. Micrometer works the same way. It has an API where you can kind of set your metrics, and whether you're using an open source metrics provider or you switch like vendors for your APM solution, no changes really required other than perhaps pulling in a different dependency in your build. And again, it has support for pretty much any backend that you can think of for sending your metrics to. Now, the great thing about Spring Boot is the actuator project auto-configures Micrometer beans for you and starts reporting metrics to it in a number of different Spring projects. I've listed it on the side here, and there's a link here if you want to check out in the deck later, but I mean, anything you can think of, they're probably already auto-instrumenting metrics for it. They're even using, in the Spring AI project, they're even instrumenting like tokens used and anything you can think of there. So in today's example, I'm going to be using a web application that has HTTP requests per second. I'm sure most people here are familiar with Prometheus, but if not, it's another CNCF project that's used for monitoring. It's really popular with infrastructure, but you can collect metrics from applications as well. Many Kubernetes clusters will install Prometheus within it. And it has a very powerful multi-dimensional data model. So you can tag your metrics with any number of tags, and then whenever you write your queries using PromQL, it's easy to kind of filter down to the exact metrics that you need based on your requirements. Now, the thing about Prometheus that's a little bit different from other vendor solutions you might think of where you're looking at your application performance monitoring is that Prometheus works in a pull model. So it needs to essentially scrape metrics from your application, where normally, like if you use a SaaS-based APM solution, you're pushing out metrics to the vendor. So Prometheus has to scrape metrics from your application. So effectively what you need to do is expose a HTTP endpoint to grab those metrics from. So in Spring Boot, again, this is really easy to do. Whether you're using Gradle or Maven, just add a single dependency here. And then in your application config, you just need to expose this Prometheus endpoint. And then once you do that, you'll see the /actuator/Prometheus endpoint will expose metrics in a format that is understood by Prometheus. Prometheus expects the metrics to be essentially the name of the metric, and then in curly braces, you have optional tags, and then the metric value afterwards. So what it looks like to set up Prometheus and having KEDA consume metrics for it will look something like this. So you have your application deployed, let's say, to your application namespace, exposing that Prometheus endpoint. And then you can deploy a custom resource called a service monitor. This typically will be installed whenever you install Prometheus. This tells Prometheus where to grab your application metrics from. And then when you install KEDA, then you have to create that custom resource called a scaled object. This will tell KEDA how to pull metrics out of Prometheus. And of course, as I mentioned earlier, KEDA will expose that metrics API to the control plane to then help drive the scaling of your HPA. So if we take a look at the scaled object configuration, this is a quick, simple example here. Kind of a key setting here is the deployment name, if you see on line number 7. And then you have essentially the triggers is where you define the scalars, and of course you can have one or more there. So this is the example of the Prometheus one. And then something to call out is the metric type. So depending on, most of them just have either average value or value, just like the HPA. The utilization is not there because there's not really a resource request in this example. But make sure that you're paying attention to this because you don't want to use average value here and then in your Prometheus query, use average there because then you'll be taking an average of an average. So just be careful there. And then some additional configuration that you might want to take a look at is, so all of that behavior for scaling up and scaling down that I showed earlier, you can configure that in the scaled object that will get translated over to the HPA. So definitely do that if you don't want to be stuck with the defaults. And then in the event that KEDA cannot fetch the metrics from wherever it needs to get them from, you can set a fallback. So let's say that you want to say after 3 attempts to fetch metrics, if it fails, then go ahead and set my replicas to hard-coded value here. So let's say your max replicas is 10, maybe you want to set that to 8 just to kind of be on the safe side. Or depending on the criticality of the app, maybe you just want to go all the way to the max. And then polling interval is how often KEDA will check, for example, Prometheus to grab your metrics. The default here is 30 seconds. Now, something to pay attention to is anytime that the HPA control plane calls KEDA to fetch your metrics, it's going to also call out to Prometheus, for example. So if you don't want to have that chain of calls always to occur, you can actually cache those. So let's say every 30 seconds, KEDA is pulling for metrics. You can essentially cache that for 30, and then 15 seconds whenever the HPA comes. And then let's say you have Prometheus scraping your application metrics. Let's say you set that to 15. So all in all, you might have like a max delay of around a minute before HPA actually gets the metrics. So that's something that you want to kind of play around with, tweak, and kind of understand how it can impact, right? Because if you have thousands of services going to Prometheus, you want to make sure you're not overloading that. So whenever you deploy your scaled object, the KEDA will create an HPA for you. And you'll notice like the owner reference section here will say it's owned by KEDA. And then if you look at the metrics section, you'll see that it's an external metric. So this is kind of what it looks like. All right, so now I'm going to get into a demo here. I just have a pre-recorded one in the interest of time, just to make sure I can fit it in the schedule. So what I'm going to be doing is I've ran a Kubernetes cluster on my laptop using micro K8s, which is a fully conformant kind of lightweight distribution of Kubernetes that I'm going to do. And everything that I'm showing here, I have in a GitHub repo. If you'd like to check it out later, it has step-by-step instructions to do everything that I'm going to be showing in this demo. I'll pull it up again too, in case you want to see that. All right, so this is just a Spring Boot, very simple project here. I'm going to just kind of expand the file system here. So, just go to start.spring.io, just create a project, have a build file and a script, K8's directory that's kind of hosting all of my Kubernetes manifests. So pretty much the simplest web app you can have here, it's just a test endpoint returning just a response here. I have a container file that I'm doing a build from just a Coreto base image here and just running a java.jar for my Spring Boot app. I have a build script here that's building my container image, and I'm using Podman. And then a cool thing about MicroK8 is it has a container registry that you can run right within that cluster. So you don't have to push anything up to Docker Hub. Like you could run this whole thing right on your laptop without even an internet connection at all. So basically what I'm doing in this script is I'm fetching that host name because I'm coming from outside of the cluster, and then I'm pushing my container image off to that local registry. And then in my deployment spec here, just basic deployment configuration here, and then you can see on line 17 is that, so within the cluster, it runs on localhost 32,000. And then I'm exposing a service down below. Just for the sake of simplicity in running this, I didn't mess around with ingress at all. So when I do the demo, I'm going to essentially do port forwarding from my local so that I can access the cluster. Now this is the service monitor resource I talked about earlier. Now this is how you tell Prometheus to grab those metrics from the actuator Prometheus endpoint here. So this is selecting my deployment, and then this is the endpoint and how often I want to scrape those metrics. The last one is the scaled object here. So I kind of showed a little bit of this earlier. So the server address is, it's a local service name that's running within the cluster in my observability namespace. And I've set my threshold to 5. And the metric I'm looking at is requests per second. So effectively, that my threshold will be 5 requests per second. And then one more thing that I've done here in the advanced section is I've defined a scale down stabilization window of 30 seconds, overriding that default of 300. And I've changed the policies to scale down only 1 pod every 15 seconds. All right, so let me jump over here. I'm going to fire up K9s, which is a cool just like CLI GUI, so we'll be able to see the number of pods easily in the background. And then whenever I create a scaled object, one of the first things that you want to do is make sure it's creating the HPA. Because sometimes if you have some bad configuration, it's not very obvious. It doesn't give you an error message or anything, so you either have to query the scaled object itself, but I like to actually go in and make sure the HPA is set up the way that I intended it to be. So if you kind of just query for that, you should see the settings here. So as we can tell, I set that scale down to 30 seconds and 1 pod every 15 seconds. And as you can see here, I didn't define a scale up, but right here's the default config that got created. All right, so now I'm going to just port forward to my demo service on 8080. Make sure that's working here. Just hit the endpoint here a couple times. Everything looks good. And then I will set up port forwarding to the Prometheus, which runs in the observability namespace. When you install that into MicroK8, there's an easy way. You just take MicroK8, enable observability, and it installs it for you. It's super easy to do. So then let me make sure that's running. And I'm going to go in and kind of pull out some metrics here before I start my load test. So the Prometheus has really awesome autocomplete, so you can just start typing something in. It'll pull up here. So what I'm going to pull up here is the HTTP server request seconds count. So this is in Micrometer what's known as a counter. It's just continuously counting up. Right. So when I pull this up, prior to this, I was running a test. So you can see these values are really high, kind of in the past. So what I want to do here is I don't want to look at the raw count. I want to look at the rate. So that's using the rate function in Prometheus, and then I'm going to say average that over the last 30 seconds. So here we can see, all right, so now this is a little bit lower. So Prometheus is actually tracking the Prometheus endpoint here. So this is where it's scraping the config. I don't really care about that. So I'm just going to add filter for my tags to just pull this /test endpoint. Of course, you could, there's Prometheus is very flexible. You could say like just exclude everything that starts with /actuator. You could say not actuator. So just make sure you're looking at your service and then filtering out any URIs maybe that you don't want to track. But for simplicity here, I'm just looking at the test endpoint. So here we can see there's the few requests that I had sent just a few seconds ago. All right, everything looks good there. Now that I can track those, I'm going to go ahead and kick off my load test here. So I'll quickly show you here. So I'm using a NPM package called Artillery. I like it it has a really quick CLI. You can do quick tests. But then for more advanced tests, it does have a lot of functionality you can define in YAML really easily. So it's one of my favorite load test tools to use. So what I'm going to do here is I'm going to send 5 requests per second for the first 30 seconds. And I'm going to go 10 requests per second for a minute, 25 requests per second for a minute, and then back down to 2 requests for a couple minutes here. All right, so let me go over. I'll go ahead and kick off that load test, and I try to chop out a couple of chunks of time here just in the interest of not sitting around. So we'll skip forward to the first ramp up. So it started at 5 requests per second. So let's go ahead and check out the metrics here. Okay, we can see that ramped up. And it should be up to 10. So now we can see on the left-hand side, a pod is already scaled up here just 12 seconds ago. And we should be up to 10 requests per second now. So our next phase of scale up would go from 10 to fast forward to 25. All right, so scale back over. We can already see that 2 more pods got added just recently. And another few seconds here. Let's check out the metrics. All right, so now we're up to 25. So that's, again, 5 was my threshold. So 25 would give me 5 pods total. So here I'm at the max. Now we'll fast forward back down to lower volume here. So now remember, if I had left this at the default, it could go from 5 to 1 after the first 15 seconds. But since I defined that only 1 pod every 15, let's go see what happens. So if you look at the time here, it might be hard to see in the top right, but around 30 seconds or so, you'll see we go from 5 to 4. Okay, so that's now right every 15. So once we get to about, I think it's around 44, 45 seconds is when we should see it go from 4 to 3. So we're at 44, 45. And then, as you can see, it'll just every 15 seconds, it'll start scaling down. All right, so once again, if you wanted to check that out, everything's on the repo. It has instructions how to set up microcades and do everything step by step that I did. So if you'd like to do it on your laptop, everything's free open source tools there. So yeah, if you're interested, you can try running that yourself. All right, now so to wrap things up, just a few takeaways here. If you're going to implement horizontal autoscaling in Kubernetes, whether or not you're even using KEDA, make sure you understand and you configure all of those behaviors unless you're okay with the defaults. If you're going to use KEDA, understand how to configure it and understand that how it's augmenting the built-in HPA. And then, Spring Boot, understand that it has those Micrometer metrics out of the box. So use what you have available for you. Micrometer does support custom metrics, but there's so much there that you could probably find what you need. And then lastly, just understand that Prometheus can easily kind of consume those metrics you provide, give those to KEDA, and then help to drive the auto-scaling in your application in Kubernetes. So with that, I'd like to say thanks, and if you'd like to leave some feedback, feel free to use that QR code and reach out to me.